Okay, next problem in induction. 1 over 1 into 3 plus 1 over 3 into 5 plus 1 over 5 into 7 and so on up to the last nth term 1 over 2n minus 1 into 2n plus 1, which is equal to n over 3n plus 1. Show by this mathematical induction method. So there are 3 parts you have to complete. Very first, you show the statements true for n equal 1. When n is 1, show true. So if n equal 1, that means first term, right? Therefore, left hand side, LHS. But the first term, 1 over 1 multiple 3, that is 1/3. Left hand side, 1 over 3, right? See right hand side, RHS. What is a right hand side? If you put n for 1, yeah, n for 1, 1 over 3 times 1, 3 plus 1, 3 times 1, 3 plus 1. Problem is n over 3n plus 1, my attitude. N over 2n plus 1, n over 2n plus 1, that is 2 plus 1, 2. Therefore, LHS equal to RHS. Therefore, LHS equal to RHS. That means the given statement true for n equal 1, right? Therefore, you can write down, therefore, the given statement true for n equal 1. Next, the assumption method, that is, assume that the given statement true for n equal p. Assume that the given statement true for n equal p, right? Assume that the given statement true for n equal p. That is copywriting. Show everything where is n replaced by p. So what is that? 1 over 1 into 3 plus 1 over 3 into 5 plus 1 over 5 into 7 plus 1 over 2p minus 1, 2p plus 1, right? Equal to what? P over 2p plus 1. Show that the statement is assumption, right? Assume that n equal p, this is true. Let's try the copywriting, right? And next word, n equal p plus 1. Therefore, if next point, if n equal p plus 1, if n equal p plus 1, write up to p plus 1 term, p plus 1's term. If it's 10, write the 11th term also. If it's 100 term, write the 100 plus 1's term, right? Therefore, continually 1 over 1 into 3 plus 1 over 3 into 5 plus 1 over 5 into 7 and up to p's term. Write the p's term. Write the p's term. Next, write the new term, p plus 1's term. Put p for p plus 1, write that term. So what is that? 1 over, what happens if we apply here? 2 into p for p plus 1, right? P for p plus 1 minus 1, first bracket. The first bracket, 2 times p into p for p plus 1 minus 1. So what is that? 2p. Here 1 times 2 minus 1, that is plus 1. That is plus 1, right? That is plus 1. And finally 1 low. Oh, ada wahalane. Semester ada wahalane ada. Hindi tiyenne me කොයිද මේ ෆුල් සිටි ඉස්සරහ තියෙනවා නැත්නම් ලොකු එකට යන්න ඕන. ෆුල් සිටි ඉස්සරහ පුළුවන්. Oh, then bank තියෙන පත්තරේ පත්තරේ මෙතන payment එකේ එතන ෆුඩ්ස් bank එකක් තියෙන බේනොස්. Oh, එතන තියෙනවා. ඒ තියෙනවා. ඒක තුල තියෙනවා. බලන්න ඕකේ දැන්. So 2p plus 2, that's 1. And well, the next one, therefore, 2p plus 2 minus 1 plus 1. Next one, 2p for p plus 1 plus 1. 2p plus 3, no? 2p plus 3. 2p plus 3, right? So I show here after. So you know, assumption answer up to p summation. Up to p summation, you know, assumption answer p over 2p plus 1. P over 2p plus 1 plus that term, right? 1 over 2p plus 1, 2p plus 3, right? 2p plus 3, the next term. Now you simplify, get the answer. What the answer to be shown? If you put n for p plus 1, if you put n for p plus 1 in the original problem, p plus 1 below what? 2 into p plus 1 plus 1. So that is p plus 1 over 2p plus 3. Ne? You have to show this answer after simplifying that. So what is that? Therefore, you know, LCM 2p plus 1, 2p plus 3 is the LCM. So modify that numerator p into here what 2p plus 3 and plus here 1, no? Okay. So multiply the bracket with p, 2p square plus 3p plus 1 over 2p plus 1, 2p plus 3. So if you factorize the numerator, the two factors can be factorized. P plus 1 into 2p plus 1, is it? Check that. Over 2p plus 1, 2p plus 3. Okay, so see 2p plus 1 cancel. The balance is the answer. P plus 1 over 2p plus 1. If you regularly follow my videos, you can see how to work this induction method. So therefore, the original problem, what n for p plus 1, that comes in the last. Therefore, it's true for every integer values. It is true for every positive integer value because of true for n equal 1, assumption n for p, hence n for p plus 1, that is true. Therefore, every integer values, this is true, right? The same question can be asked in the sigma notation. Because I worked the 2020 and 19, everything I shown last previous videos. So the similar problem can be asked sigma. How there? Sigma notation. How there? I raised that. Check sigma. What the common term? 1 over 2r minus 1, 2r plus 1, r equal to from 1 to n. This is equal to n over 2n plus 1, right? By using mathematical induction, show that sigma notation. The same method I worked couple of question previous videos, the sigma notation. See next question. I work 1 over 1.4 1 into 4 plus 1 over 4 into 7 plus 1 over 7 into 10 and up to plus 1 over 3n minus 2 into 3n plus 1. Using the induction, show this summation equal to n over 3n plus 1. Show this summation equal to 3n over 3n plus 1.
කච්චේගේ බැංකු කච්චේගේ ගාව මේ බැංක් අවුට්ලෙට් එකක් තියෙන බස් නැගිලා තමයි. එතන ඔක්කොම මැෂින් එක දාන්න පුළුවන්. තමයි පස්සේ මට තියෙන මෙතන තියෙනවා සියලු බැංක් මැෂින්ස් ටිකක් තියෙනවා. ඔව්.
So if n is 1, show prove LHS induction method. Very first point, n for 1 over 1 into 4, that is 1 over 4 LHS. Next right hand side RHS. Again for 1, 3 times 1 plus 1. So no doubt 1 over 4. Therefore LHS equal to right hand side, right? Next next sentence assume that the given statement is true for n equal p, right? Given statement is true for n equal p. So if n equal p, true assumption, right? Let's copywriting 1 over 1 into 4 plus 1 over 4 into 7 plus 1 over 7 into 10 and up to plus 1 over 3p minus 2 into 3p plus 1 equal to what? P over 3p plus 1, right? 3p plus 1. Yes, the assumption say this is true for n equal p. Next we write p plus 1. If n equal p plus 1, if n equal p plus 1, right? If n equal p plus 1, that means up to p terms and write the other term, p plus 1's term, right? So what is up to p term? 1 over 1 into 4 plus 1 over 4 into 7 plus 1 over 7 into 10 and write the pth term 3p minus 2 into 3p plus 1 3p minus 2, 3p plus 1. So the other term, p plus 1's term, that is 1 over, what that if you apply 3, if you put p4, p plus 1, p4, p plus 1 minus 2, put p4, p plus 1 minus 2. So multiple 3p plus 3 minus 1 plus 1. Okay. Therefore 3p plus 1, 3p plus 1. But the other answer 3p minus 2. 3p here plus 1 comes, what happened? 3p plus 3 and 1, 4. Okay. 3p plus 4. 3p plus 4, right? 3 more, see 3 more, 1, 4, 4, 7, 4, 7, 10, 3 more. So that's the answer, LHS. Next we have to show, if you completely simplify what is the answer. So stop the video. Now you think what the answer should be. If you write n for p plus 1, p plus 1 over, p plus 1 over 3p plus 1 plus 1. That means p plus 1 over 3p plus 4. 3p plus 4. To simplify everything, answer should come like that. P plus 1 over 3 into p plus 1 plus 1. So we simplify that. So therefore, first p summation, your assumption answer. Up to p number additions, your assumption answer. That is what? P over 3p plus 1 plus additionally 1 over 3p plus 1, 3p plus 4. Now simplify this completely. Try to get this answer, p plus 1 over 3p plus 4. So like the previous question, same idea like the previous, use the LCM method. So what is that LCM? LCM method, 1 over 3p plus 1, 3p plus 4 is the LCM. So here p, with the p you multiple what? 3p plus 4, ne? 3p plus 4 and plus 1. Is something algebraic fraction simplifying. So simplify, you know the answer what should be, right? So what is that? 3p square, I write here, 3p square plus 4p plus 1 over 3p plus 1, 3p plus 4. Then what is that? Numerator, factorize. Factorize the numerator. It becomes p plus 1 into 3p plus 1. Check that. Okay. Over 3p plus 1 into 3p plus 4. So see this cancel. Remaining is the answer. Is it okay? That's the expected value, expected answer. Well, under p plus 1 over, can I write the 3p plus 4 like this? 3p plus 4 like that pattern, no? 3 into p plus 1 plus 1. Therefore, the original problem, if you substitute n for p plus 1, what to be? n for p plus 1 දාපුවම කොහොමද එන්න ඕනේ? ඒ උත්තරය එනවා ඇති. n for p plus 1 පෙරදීට සෙයිදාල්. What the solution to be? n for p plus 1, n for p plus 1 plus 1. So it's true. Therefore, therefore, the given statement true for every integer value of n. Therefore, the given statement is true for every integer values of n, positive values of n. I'll show another question. I show the sigma notation. Sigma 1 over 2 to the power r equal 1 to n. Show that 1 minus 1 over 2 to the power n. Using mathematical induction, show this answer. Most papers are recently they put the sigma notation. So what do you mean sigma? Addition. Put r for 1, 1 over 2. Put r for 2, 1 over 4. Put r for 3, 1 over 8. Put r for 4, 1 over 16. All additions. සියලු එකතුව මේ උත්තර එන්න ඕනේ n දක්වා up to n terms addition. Then follow the pattern of induction. Within 3 steps you have the answer, full answer, 25 marks every year. First paper, first question, simple case. One of the problem that I work in many, our tube problem, the future questions. So if n is 1, LHS, right? Left hand side, sigma 1 over 2 to the power r equal 1 to n, okay? So what the answer? R equal 1 to n. N is 1 here, n is 1. Therefore 1 to 1, right? 1 to 1 means only first term, one term. So what is that? That is 1 over, r is 1 and 2. Left hand side is 2, right? If you put n for 1, left hand side answer is 2. Next we find RHS right hand side. But the other side, 1 minus 1 over 2 to the power 1. That is 2, ne? So what is 1 minus half? Therefore LHS equal to RHS. Therefore left hand side equal to right hand side. That is the given statement true for n equal 1. The given statement true for n equal 1. Okay. Next point, assumption. Assume that the given statement true for n equal p. Assume that the given statement true for n equal p. The given statement true for n equal p. That is straight copywriting. Balalivima. Sigma 1 over 2 to the power r equal 1 p. That's equal to what? 1 minus 1 over 2 to the power p. That's all. Let's try it. Copyright. Where is n? Say p, right? Okay. Next, come apply for n for p plus 1. The main step there for next point. Next point, n equal p plus 1. If n equal p plus 1, that means add up to p plus 1 term. What do you mean p plus 1? If there are 50 number, 50 plus 1, 50 first term. If it's 100 number, 100 plus 1, that one. 20 numbers mean 20 first number, right? That's the meaning of this sum of n p plus 1 terms. So what happens if n equal p plus 1? LHS sigma, or you can start p plus 1 means sigma 1 over 2 to the power r equal 1 to what? P plus 1. 1 to 100, 1 to 1000, 1 to 58, like that. 1 to p plus 1's term. So we don't know what is p. Up to additions you can't collect it p plus 1 term summation. So here I can break into 2 parts. See, for example, 11 number added. Can I write that? Up to 10 number and add the 11th number. If you want to add the 25 numbers, can I say all the answer for 24 terms and add the new 25th number? That's the case, right? So in this case, I can say sigma pattern up to p plus 1. I can say from 1 to p and the p plus 1's term. So it is sigma 1 over 2 to the power r, say r equal 1 to p, r equal 1 to p, and write the p plus 1th term, p plus 1. Usually here we call the term is like a u. You learn the primary grades, the tn equal tnth term, tn. Here we call u, we put a u term, u of p plus 1. That means p plus 1 padaya, p plus 1th term, right? Therefore, always by induction method, when you complete the last part, you need the previous assumption value. So you know up to sigma, this up to p summation, answer is this, okay? So apply 1 minus 1 over 2 to the power p plus, what is p plus 1th term? What is p, if you want R42, put R42, put R43, R47, R4P, apply. P plus 1 means put R4P plus 1. So what the P plus 1th term? 1 over 2 to the power P plus 1. Okay. So an important question, the simplify method. So try to improve these simplification ideas. You now stop the video, stop the work, and quickly roughly decide what the answer to be. If you simplify everything, what's the answer to be? In this original problem, 1 minus 2 to the power n4p plus 1. Okay. If you simplify, try to take this 1 minus 1 over 2 to the power p plus 1. So go that proceeding for that step. So I show here 1 minus 1 over 2 to the power p, okay, plus 1 over, can I write p plus 1? You know indices rule says it correct. Indices rule method, bases are same when you multiple at the power. Okay, so therefore 1 minus, see, can I take some common factors? Here 2 to the power p, here 2 to the power p there. Take out, take the 2 to the power p, take the 2 to the power p out. Take the 2 to the power p out as a denominator, right? So what inside? 1 positive I took, negative say minus, ne? 1 over 2, okay? 1 over 2. So therefore, 1 minus 1 over 2 to the power p, what is the bracket? 1 minus half, half. So therefore, 1 minus, here see 1 times 1, 1. Bases are same when you multiple at the power. What is the requirement? What the requirement? That's the answer that we need when you straightly apply for n4 p plus 1. That is available. See there. Therefore, this is true. This formula, this sigma notation, or this theory or statement true. You can write therefore the statement true for every positive integer n. This is the way how to work this induction method. I completed my Zoom lessons and forward to I upload to YouTube. The same in that order. It's my fourth or fifth video of induction. I shown here 3 questions. Expect some more from this my YouTube channel. So please subscribe this, then you can get a lot issues in combined maths problems, revision papers, model papers, expecting questions, theoretical parts, everything.